Hello everybody, my name is Shailendra Kumar and today I will be taking up the topic of fluids. So what exactly is a fluid? So before going into the details of the mechanics of fluids, let us try to understand some of the properties of fluids. So one of the property of fluids is that fluids do not have a definite shape of their own. So they don't have a shape of their own. That means they take the shape of the container in which they are present. Same is the case of gases. So gases also don't have a shape of their own. So gases and fluids, they are shapeless, we can say, or they take the shape of the container in which they are present. Now, why are fluids called fluids? The reason is, the name is given because they are free to move, they are free to flow. So fluids and gases are those states of matter which can flow. That's why they are called fluids. So they can flow. Third thing is, fluids, they have a very low compressibility. That means it is almost impossible to compress a fluid. Compressibility is very low. Very low. Minimum. They are in fact, the definition of an ideal fluid is that it is incompressible. But most of the fluids, they are having a very low compressibility. Fourth thing about liquids is that they are almost offer no resistance to shear stress. So no resistance to shear stress. So what is a shear stress? Shear stress is, for example, if this is a mass and if I apply a force here and I apply, then if this is a liquid or a fluid, then what will happen if I apply force in this way? This force is tangential to the surface. What will happen? Will the liquid be affected? Not at all. So there is no resistance to shear stress. Or if I have another force which is acting at this point. So in this situation, there is no shear stress experienced by the liquid. So these were some of the points about liquids. Now next, why should we study about fluids? What is so special about them? First of all, fluid is a state of matter. Among the three states of matter, fluid is a state of matter. That's why it becomes very important to study about the nature of fluids. And almost 2/3 of the surface of Earth is water. Then it becomes very important to study about liquids or fluids. And last but not the least, we are surrounded by a layer of atmosphere, which is air. So air is surrounding us. So fluid and gas, they form an important part of the atmosphere of the Earth. So we should learn about its properties. So in this chapter, however, we will be focusing on fluids. Gases are studied in some other topics. So we will be focusing on fluids. Now the next thing, the property of a fluid. What is the property? When the fluids are at rest, fluid at rest, let us say the fluid is at rest, then in such a situation, now let us go through some of the terms. First of the term is thrust. So let us understand thrust. Thrust is a normal force. It is a normal force. Force applied on a surface in a direction perpendicular to the surface is called a thrust. I repeat, force applied on a surface in a direction perpendicular to the surface. Let us take an example. say this is a plane surface and I have cube, or say I have a mass m, and say this area is the area over which this mass is present. Now what is the thrust? So in this case the thrust is simply the weight of the mass, which is mg. The thrust is m times g. Second, let us try to reorient the mass again. Say now it is like this. This is again m. Again the thrust will be what? If I have a mass of 2m, in that case what will be the thrust? It will be 2 times m g. So thrust is nothing but it is just a force, and it is a normal force, right? Look at the direction of the force of this surface. This is making an angle of 90 degrees. So it is a normal force. Let us take another example. So this is an inclined surface. In this case, what is the thrust on the surface? The mass of the solid is m. Then the component of the mass normal to the surface, this angle is theta, this is theta. Then it will be the component of this mg along the normal surface. So this will be the thrust in this case. So in this example of an inclined plane, the thrust is not equal to m times g. It is m times g into a factor which is depending on the angle. It will be mg cos theta. You can verify if the theta becomes 0, then this plane becomes, inclined plane becomes a horizontal plane. And then mg cos theta becomes mg. So these are the examples of thrust. So thrust is a normal force onto a surface. What are the units of thrust? What are the units of thrust? Thrust is measured in the same units as force is measured. So the unit is Newton or dyne. Newton is the SI unit and dyne is the CGS unit. What are the dimensions of thrust? Dimension is same as that of the force. Force has dimensions of mass into. So these are the dimensions of thrust. Now let us go to the next topic, next concept, which is pressure. Pressure is again a physical quantity which is defined as the normal force acting per unit area. Normal force acting per unit area. So this is pressure. Let us try to understand this with example. Say this is a mass m and this is lying on a surface whose area is A. What is the thrust? What is the pressure in this case? Pressure P will be force per unit area. In this case, the force is the weight of the body, which is mg, which is acting downward, mg, and the area is simply given, it is A. So this is the pressure. Let us take another example. Say, let us take another example. Say this is a horizontal surface where a man is standing, the weight of the mass of 10 kg, standing on this, and say in this case, say the area over which he is standing, that means area of his foot is say 25 centimeters square. So it is 100 centimeters square, and the weight of the person is 50 kg, and he is holding a weight of 10 kg, or a mass of 10 kg, and the person has a mass of 50 kg. In that case, what will be the pressure exerted by his feet on the horizontal surface? So in that case, pressure will be force by area. It means, what is the force? 50 kg plus 10 kg is 60 kg. So 60 G. What is the area? 100 600 divided by 100 into 10 to the power minus 2. This is the pressure. This value you can find out. 10 to the power minus 6 into 10 to the power 6. Find out this is equal to 6 into 10 to the power 8 Newton per meter square. This is the value of the pressure. Now let us find the units of pressure. What is the unit? It is force per unit area. That means to be measured in newtons per meter square, or in the CGS units it will be line per centimeter. So these are the two units, SI unit and the CGS unit. There are some other units of pressure which are popular. Let us list them. 1 ATM, 1 atmospheric pressure. This is equal to 76 centimeter of mercury column. This is the 1 atmospheric pressure. Just to remind you one thing, 1 Newton per meter square is equal to 1 Pascal. Another unit is bar, and 1 bar is equal to 10 to the power 5 Pascals. 1 ATM is 1.01 into 10 to the power 5. Another unit is torr, and 1 torr is equal to 1 millimeter of mercury. About the nature of pressure from the vector scalar point of view, pressure is a scalar. Don't confuse here. We define pressure as force per unit area. Force is a vector, but we are saying pressure is a scalar. The reason for that is because the direction of pressure is already known. For example, this is a surface over which a force is acting. This is a surface on which a force is acting. We define pressure as a normal force acting on a surface. So the force may be acting in any direction, but we take only the normal component of the force. For example, force is acting like this. This force is a vector, but the component of this force in the normal direction. This is the normal component. So this normal component of the force acting per unit area is the pressure. And since we are taking a normal component, such force is not considered to be a vector. So it is a scalar quantity. Okay, with this we end this topic for the time being. In the next class we will be discussing about liquids in more detail. Thank you.